Hello everyone, this is the continuation of last class of the chapter Human Eye and the Colourful World. That is chapter 2 from class 10 MBOSE science textbook. Let us begin. Now I will start with the topic Dispersion of white light by a prism. Okay, let us first know what is a prism. You see, this is a prism. Right? It is made up of a piece of glass or any transparent material. Alright, you can see that this side and this side are in triangular shape. This side and this side are in rectangular shape. So a prism is a piece of glass or any transparent material bounded by two triangular surfaces and three rectangular surfaces. Alright, these rectangular surfaces, they are known as refracting surfaces. Alright, and the angle between this surfaces, this refracting surfaces and this refracting surfaces, this angle is called the refracting angle or the angle of prism. Alright, now this line along which the two refracting surfaces meet, this line is called the refracting edge. Alright, and this is the refracting edge, right? So any section in a prism which is perpendicular to this refracting edge is called the principal section of the prism. As you can see here that this section is perpendicular to this refracting edge. So this section is called the principal section of the prism. Isaac Newton, while studying the heavenly bodies, he observed that the image of the stars were colored near the fringe. Alright, he thought that there is something wrong with the lens, so he polished the lens of his telescope, but then also the color still persists. So he concluded that the fault is not with the lens, so there is something with the nature of light itself. Alright, so to this conclusion, he proved some of the experiment. Okay, one of his experiment is in a dark room. He allowed sunlight to pass through a small hole. Alright, he allowed sunlight to pass through a small hole, and then he placed a prism in the path of beam of light, and then projecting the light onto the white screen. Alright, he observed that a band of 7 colors appear on the white screen. Right. The order of these colors from the base was violet, indigo, blue, green, yellow, orange and red. You can also easily remember this order of color by a word Vibgyor. V-I-B-G-Y-O-R. Okay. Next is dispersion. The next is what causes dispersion of white light. Alright. White light is composed of different colors which have different wavelength. Alright, so the bending of this light, alright, is inversely proportional to its wavelength, which means if the wavelength is bigger, then the bending of the light will be a little bit. If the wavelength is smaller, then the bending of light is bigger. Alright, what is wavelength? Let me draw a wave. This is a wave. Alright, so these are called crest and these two are called trough. Alright, now the distance between these two successive crests is called wavelength. Right? Or the distance between these two successive trough is called wavelength. Alright, if you look at this figure, you will see that the violet light has the lowest wavelength. Alright, so the violet light has the lowest wavelength, so it will bend more. Alright, but this red light has the highest wavelength, so it will bend only a little bit. You see that these wave of different colors, alright, have different wavelength, so they will bend in their different angles. Alright, and this wave travel with the same speed of light in vacuum, that is The speed is 3 into 10 to the power 8 meter per second. One of the example of dispersion of light in nature is rainbow. Alright, surely we all have seen rainbow. Alright, rainbow is produced due to the dispersion of white light through these tiny water droplets suspended in the air after rain. Okay, so these tiny water droplets, they act as innumerable small prism. Okay, you look at this figure. Alright, this is a tiny water droplet. Alright, so when the white light from the sun incident on this water droplet, alright, here at this point it gets refracted and dispersed. Right, so it gets refracted and then dispersed. You will see here on the other side of this droplet at the point C. Right, so at this point C, this dispersed ray suffer total internal refraction of spectrum. So it will move to this side. Alright, so it will move to this side. You can see here at this point D. Right, at this point D also this ray will suffer refraction, right, and emerge out as a band of 7 colors in the form of a circular arc along the horizon. The next topic is atmospheric refraction. Okay, atmospheric refraction. Atmospheric refraction is the deviation of light or any electromagnetic wave from its straight line when it passes through the atmosphere due to variation in the air density as a function of height. Let me give you one example due to atmospheric refraction, that is twinkling of star. Alright, when we look at stars, alright, when we look at the stars in this Earth surface, alright, so we are viewing them through a thin layer of turbulent or moving air in the Earth's surface. Alright, so the next topic is scattering of light. Alright, what is scattering of light? When an incident ray of light, suppose this is a particle, alright, this is a particle. Alright, when an incident ray of light strikes on this particle, this is an incident ray of light strike on this particle. Alright, so you can see here that the diameter of this particle is greater than the wavelength of this incident light. Right, so what happened? This incident light first get observed by this particle and then it transmitted in all possible direction. This is called scattering of light. Alright, let me give you another example. Suppose if there is another incident light, alright, whose wavelength is bigger than this diameter of this particle, then this incident light will not get observed by this particle. So it will continue moving in its direction. Alright. So next, the next is let me give you some common phenomena of atmospheric scattering. Okay. Now we all have seen that red light is always used as a universal danger signal. Alright, you can look at this figure. Alright, why do red light always used as a danger signal? Alright, let me draw. We know that the wavelength of red light is the highest. Alright, is among all other colors. The wavelength of red light is the highest among all the other colors. Alright, so this red light will be least scattered. Alright, this red light will be least scattered, so they can easily pass through fog or smoke without getting scattered. Hence, we can see red lights also from a long distance. Okay. The next is, why do sky appear blue? Alright. When the white light from the sun passes through the atmosphere, we know that in the atmosphere there are gases, there are particles, right? There are molecules, right? So when the white light passes through the atmosphere, right, these incident light, alright, they first absorbed by this particle. After they first absorbed by this particle and then scattered. Alright, so but blue light scattered the most. Why blue light scattered the most? Because it travelled shorter and smaller wavelength. So this is the end of this chapter. I hope you have understood through all my lecture. So thank you so much. Stay safe and stay healthy.